We are going into vectors today. So we're still in Unit 15, but we're going to be talking about vectors for the next couple of days. So first of all, a little introduction to vectors. A vector has both magnitude and direction. Okay? So for a vector, we have an initial point, and the vector goes off into a direction, and it does stop. I know that it has an arrow here, but that arrow does not mean it keeps on going. You can have very short vectors, you can have very long vectors, whatever. So it does have magnitude. That means it has magnitude. So a vector has direction and magnitude. So those are the two components of a vector. So it has both. They have both direction and magnitude. Okay, so first of all, that's the first thing I wanted to tell you. The next thing that we're going to do with vectors is we are going to add them. We're going to multiply them by a scalar. If I wanted to find 2 times u, I would take u and I would want to keep the same direction, just multiply its magnitude by 2. So it would go off in the same direction. Okay, I would just multiply it by 2. Let's see if I can do that here. So what I have in pink right over that would be 2u. So same direction, I just double the length. Okay. What do you think over here? Let's do negative. What would negative 1 times w do you think? Negative 1 times w. Same direction but flipped. Same length but flipped. So how long is this? About 1.5. So I'm going to make that 1.5 this way. So negative w would be over here. So if this is w, then this would be negative w. Okay? All right. What else about vectors? Oh, to denote a vector. To denote a vector, you see I have my letter, my name of it, and then I use this little vector notation up on top. That just means that it is a vector. Okay? That distinguishes it between a vector and another variable. All right? Okay. Next up, we are going to add vectors together. I'm going to add vectors together, and I'm going to use s and z here. So I'd like to find s plus z. So the first thing I do to add s plus z is to draw z, or to draw one of these. I can draw either one. It's going to be easier to draw z since it's kind of going straight down. It's a little over, so it's about there. Okay, I'm going to draw it. I'm going to go to the end of s, and I'm going to draw z over here. So there is vector z. Okay? So I just copied it over. Well, I tried to copy it over. It looks like I made it a little bit too long. So let's shrink it a hair. We'll do that. Oh, my little whiteout. Okay. Is that closer? I think that's a little closer. So this should be exactly the same magnitude and exactly the same direction. Okay, if we want to add these two together, there are 2 ways we can do it. One way is to make a little parallelogram out of this. Okay, make a little parallelogram. The sum of the vectors is going to go from that initial position out to the corner of the parallelogram. So that's one way to draw it. We're just going to sketch these, okay? And then we're going to find values when we're going to do that algebraically in a second. But just sketching it, that's visually what it looks like. So I'm going to sketch vector s on the end of vector z. trying to do it nicely. Okay, and then I'm going to sketch vector z on the end of vector s. Where those two intersect is the terminal point of our sum vector. So I'm going to draw our sum vector now out here, and that is s plus z. Okay? Okay, what if I wanted, well, what if I wanted, let's do w minus v. Let's do w minus v. Here's w, here's v, right? So I'm going to draw, first of all, I need negative v. I need negative v. So negative v would be the same magnitude here. Looks like it's about to here. Same magnitude, but in the opposite direction. So about there. So this would be negative v here. Okay? So I'm going to draw this endpoint on this endpoint of w. I forgot now how long that was. Okay? About to there. So I'm going to draw this endpoint here. And I'm trying to do it in the same direction. Make those the same direction. Okay? And now I draw the parallelogram. So I'm going to draw this over here. And once again, I've forgotten how long that is. Okay, right there. Okay. So I'm drawing that over there. Does it go all the way down here? Yeah. Okay. All right. And then I'm drawing W on its end, so I'm making that little parallelogram. And if you don't have to get a straight edge to do this, I want you to have an idea of what these sums look like. And then the sum vector would be right here. So this would be W minus V. Okay? That's how you would do a subtraction one. First do the negative, then add. Okay? Far, far easier to think of adding than subtracting these. Okay? So that is how you will do numbers 1 and 2 on your worksheet. Okay? Now for the rest of these, I'm just going to, I might play around with these a little bit for your notes. We might do a couple of these. So we can also be given the coordinates. These would be like the terminal endpoints of your vector. So I could graph that. I could graph you. I could graph you by graphing the point, that terminal point. So -4, -1 is right here. So the vector looks like that. Okay? For V is 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. So V looks like this. So there's vector V, there's vector U. Okay? So when we add these two together, we could do it visually, but we can also do it very easily algebraically. Okay? So algebraically, what this looks like is we very simply add their coordinates together. So here is vector U, here is vector V. We just simply add their coordinates together. We add the horizontal coordinate and the vertical coordinate. So this will be -1, 4. These vector notation bars, how I call them, I'm not sure exactly what they're called. They might be called most of my students like to call them chevrons. I don't know if that's accurate. This just reinforces the fact that we do have a vector. We are dealing with vectors. So instead of parentheses like a point, these are vectors. Even though they do behave like points, we can graph them like points and so forth. So these two would intersect at -1, 4. Does it look like that's possible? It does. I mean, given my little graph there. Okay? So that is how we will do those. So you can multiply by a scalar to multiply by a scalar. I don't want to do this example because I think that's the only one you're doing. So let's do another one. Let's do 3w minus u. Okay? Let's do 3w minus u for an example. So 3w would be 30, negative 33, plus negative u would be 4, 1, yeah? And then add your coordinates, and we get 34, negative 32. Okay, so that's how you have a scalar multiplied by your vector, and you can subtract or add. I like to multiply by a -1 and then add. Okay. Next up we have magnitude. Let's go back to my vectors here. Let's see how we could find the magnitude of a vector. I think I will draw a new vector because I've marked those up pretty good. Okay. I think I will, you know what I'm going to do? Well, I'm going to just draw a vector here. Okay. Let's say here's my vector. And we want to find its magnitude. We want to find its magnitude. That means we're finding the length. Magnitude is the length. You may be asking, why don't they just call it the length? I don't know. They just call it the magnitude. Not sure why. Okay, but it is length. You can think just length. Okay, so magnitude is length. We want to find the length, and let's pretend that my straight edge here does not have any little marks on here that we can actually measure, right? So, but we do know, let's say that we know the coordinates. So we're given the coordinates are, let's say, AB. Okay. So what that means is, if we were graphing this on a set of coordinate axes, that this point out here is the point AB. So if I wanted to know that length, this length is A, this length is B, how can we get that length? Well, this is a right triangle, and we can just use the Pythagorean theorem. So this length will be the square root of a squared plus b squared, because the hypotenuse squared is equal to the sum of the squares of the legs of a right triangle. So the magnitude is simply the square root of a squared plus b squared, if the coordinates are a, b. So let's see. Let's come and let's find the magnitude of W. Okay, the magnitude of W. This notation means magnitude. Okay. Also, this notation means magnitude, by the way. Okay. I think the reason we don't use that for pre-calculus is because I don't want you to get confused with absolute values. But it is the same. Okay, magnitude. All right. So square root of the square of 10 plus the square of negative 11. So that will be 100 plus 121 under that square root, which is 221. That is the magnitude of W. That's it. That's all there is to it. Alrighty? Okay. So we can denote, get another piece of scratch paper here. We can denote vectors. We can denote a vector in that form, or we can denote a vector in this form. A times I plus b times j. It's just another form of how to write a vector, okay? It means exactly the same thing, though. When I see this form, I think that is AB. That's what I think. So if I give you that vector u is 3i plus 2j, you can just think, okay, that means 3, 2. All right? This form is convenient for some things that we do with vectors. Okay? So in this one, let's say that I give you that that u is 3i plus 2j, and let's say I give you that v is negative I plus 4j. Okay? Well, we can add u, and we can add u plus 2v. We could add u plus 2v. Let's do that. So that would be u is 3i plus 2j, right? 2v would be 2 times each of these, so 2v would be negative 2i plus 8j, and we add those together, and that would be I plus 10j. So that is u plus 2v. Okay? What if we wanted to find the magnitude of u? Well, the magnitude of u would be the square root of 3 squared plus 2 squared. 9 plus 4, 13. Okay, and that is it for today. That's all we have for today. So that's what you'll do with these. Find the magnitude, find a sum, do a little scalar finding of sum, things like that. Okay, little magnitudes.